The National Electrical Code, specifically Tables 310.15b16 through 310.15b19, dictates current carrying ampacities. For example, a single number 3/0 THHN conductor has an ampacity of 190 amps when using 75 degrees Celsius conductors. When installing three number 3/0 THHN conductors in a 2-inch conduit, no derating is required. This is because, according to Table 310.15b16, a 2-inch conduit can accommodate 264 amps of 75 degrees Celsius conductors without needing derating. However, if you install 6 number 12 THHN conductors in a 2-inch conduit, derating becomes necessary. Table 310.15b16 indicates that a 2-inch conduit can handle 90 amps of 75 degrees Celsius conductors without derating. With 6 number 12 THHN conductors, and assuming each pair is in the same circuit, they are carrying 90 amps multiplied by 2, totaling 180 amps within the 2-inch conduit. This necessitates derating, as per Table 310.15b2 and other associated tables. The reason number 12 wires can generate more heat in this scenario is directly related to the amount of current they carry. Greater current flow leads to increased heat generation. In the example, the 6 number 12 wires collectively carry 180 amps. While it might seem counterintuitive, this is compared to the 3 number 3/0 wires individually carrying only 190 amps, but that is for 3 sets. Derating factors are applied when the number of current carrying conductors in a raceway or cable exceeds 3. The NEC defines current carrying conductors as those that carry current continuously for 3 hours or more. Grounding conductors and equipment bonding jumpers are not considered current carrying conductors for derating purposes. Derating factors are applied to the allowable ampacity of the conductors as specified in Table 310.15b16. These ampacities are based on an ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit. If the ambient temperature exceeds 30 degrees Celsius, then additional temperature correction factors must be applied. These temperature correction factors are found in Table 310.15b2. The NEC provides tables that list adjustment factors for various numbers of current carrying conductors. For example, if there are 4 to 6 current carrying conductors in a raceway or cable, the allowable ampacity of each conductor must be reduced to 80% of its original value. For 7 to 9 conductors, the ampacity must be reduced to 70%, and so on. These derating factors are cumulative. If both the number of conductors and the ambient temperature require derating, both factors must be applied. For example, consider a scenario where you have 7 number 12 THHN conductors in a conduit and the ambient temperature is 40 degrees Celsius. First, you would derate the ampacity of the number 12 conductors to 70% due to the number of conductors. Then you would apply the temperature correction factor from Table 310.15b2 for an ambient temperature of 40 degrees Celsius, which might be around 0.87. Final allowable ampacity would be the original ampacity of the number 12 conductor multiplied by 0.70 and then by 0.87. Understanding these concepts is crucial for safe and compliant electrical installations. Proper derating ensures that conductors do not overheat, which can lead to insulation breakdown, short circuits, and potentially fires. Always consult the latest edition of the NEC and qualified electrical professionals for specific applications.